So today's focus would be a little bit of SQL, some advanced SQL concepts. Then we'll look into how to connect a database to an ASP.NET Web Form in section 2. That'll be a separate video. You've got quiz 7 due on Monday as usual. Assignment 5 is published. Group report 8 is on D2L as well. By the time we're done with this video, you should be able to tackle most of those assignments. So let's get started. First thing you want to do is get this link in D2L on the lecture slides. That should bring you to a W3 Schools page where we get a nice interface for practicing some SQL. I want to get you outside of the tool first, so you're not worried about SQL Server or Visual Studio. Just learn plain SQL, nice and easy with a very simple, easy interface. So this web page points to a database that's an e-commerce database, something we're probably familiar with. It's got a table called customers with 91 rows or records in it, employees, there are 10 of them, order details, orders, products, shippers, suppliers, categories, so on and so forth. So we're going to query some of these tables and return some data and use that as a basis for learning SQL. All right, so let's go right into it. What is SQL? SQL is a structured query language. It is standard across all relational database management systems. What we need to know is that there are two different versions of SQL. There's a data definition language, DDL, for creating, updating, and removing tables, indexes, triggers, views, stored procedures, so on and so forth. For the sake of this class, we're going to deal with the basics. So we would only be creating tables. But we don't even need to know how to write data definition language versions of SQL because we're going to use a web interface or a Visual Studio interface to create tables when we need to, right? But in advanced classes, you might need to know how the create table statement works. So we're going to be focusing on data manipulation language, the DML side of things. It turns out there are only 4 basic concepts we need to understand in SQL, or commands, if you will. Because the basic functions you can do in SQL is adding some data to a table, which we would call inserting, updating, changing, or modifying or altering some data in a database table. That would be the update command. Adding data or inserting data would use the insert command. Deleting data or removing data from a table would use the delete command. And what we're going to do 90-something% of the time when you're using SQL is actually retrieving, displaying, showing, fetching, getting data from a database table. I'm just giving you a couple of synonyms because sometimes students get confused on when to use what command. If you're retrieving data, you want to use a select statement. If you're adding some data to a table, somebody goes to your registration page and they click register or create account. Well, you're going to be creating a new row in a table, so you need an insert statement. Somebody goes to the change password screen and they're changing their password or they're updating their profile, changing their profile picture. That is going to involve an update statement. They want to delete a row from their cart, so they delete something from a cart, remove something from a cart. You have to start thinking behind the scenes. Removing something from the cart means we need to call a delete SQL statement. And when we're showing a list of products, or you're in a search results and you're seeing a list of values, or you go to a product page and you could see some product information, that would involve using a select statement. If you can get those 4 things clicking in your head on when to use what, the rest is just figuring out what the right syntax is, and life becomes a lot easier. So CRUD is short for these 4 functions. C for create, which is an insert statement, R for retrieve, which is a select statement, U for update, D for delete. Right? So this is the basics of SQL. So let's get into the syntax of a select statement, because that's what we're going to be doing most of the time. The basic format for a select statement looks something like this. So now I'm going to zoom out a little bit so you can see my screen. There we go. So basic select statement looks something like that. Typically you would see some semicolon. We don't really need it. It's not required for what we need to do. We're going to skip that. So typically you'd have select a list of columns, comma delimited list of columns, right? So column 1, column 2, and then we need to know what table it's from. Now it's important to note that SQL is not case sensitive in terms of when we type in the command names or the column names. So it doesn't really matter if this is uppercase or lowercase. So I have in here select star from customer. Star is a wildcard, right? That means retrieve all columns. If I don't know all the columns in this table, I know the table is customers. You ought to know the name of the table because you can't spell this as customer if your database actually has a table called customers. So you need to make sure you know the name of the table in the database that you're going after, right? So select star from customers, click run SQL. That shows me 91 records, right? And I've got a bunch of columns in this table, and a bunch of rows. So you're not dealing with a very complicated tool. Very simple tool, allows you to type in some SQL. And once we get a hang of it, we're going to go into SQL Server and play with SQL Server, right? So supposing I'm interested in seeing only 2 columns, the customer ID and the customer name. Maybe I want to see the country and the city, right? So I would list the columns here. It's comma delimited. There's no comma at the end, right? And I would have from customers. This is the name of the table. So list of columns, table. I still have 91 records coming back, but you can see I only see these 4 columns. So that's the basic structure of SQL. So now you should be able to answer a couple of your lab questions. Let's go back to the lab. So write a query to retrieve all rows and columns from the customers table. We've kind of done that already. So you should be good to go. Write a query to return the product name and the price values from the products table. So in this case, we're looking at only 2 columns in the table called products. So you've got the basic structure for doing that, right? Try to follow along the lab exercises as we go. All right, so let's go to the next page. So it turns out we can filter rows by using a where clause. When we need to filter rows, we would add a where clause, right? The where clause should come after the from clause. So we would have something like where. And notice I use 2 dashes. So in SQL, you can use 2 dashes to prefix a comment. So I'm only using this to kind of show you the structure. So I have select list of columns from. Well, I could use wildcard to replace all of these to show me all columns. And the where clause requires you to have a column name and then one of these operators. Okay, so I could do where a column name customer. Actually, let's go for country. I have to be able to spell the exact column name, right? Where country, and then I plug in one of these operators, right? So let's say country is equal to Germany. Now notice what I just did. So this will be the value. So you need to know the column name, some operator, and then some value. Anytime we're going against textual data, textual string, date, time, columns that hold these types of values, we're going to need to use single quotes around the actual value that we're testing for inside of that data cell, right? However, if we were going against numerical values, then we would not have single quotes. Let me repeat that. If we're using numerical values, and if you remember what we talked about last week, we're going to use numerical values for all our primary keys. That's just a good best practice, right? So customer ID, for example, is going to be a number. This website is smart enough to be following those best practices, as you can imagine. So customer ID being a numerical value, if we're testing for customer ID equals something, we're not going to put single quotes around it. Okay, just go ahead and run this. So we can run, look for things where, let me get rid of this comment so we can focus in on the right. So in this case, I come up with 11 records. All these customers are from Germany, right? Let me try to see if I can get some results if I change this to lowercase g for Germany. When I run this, I get no results. What that tells you is that inside of this double single quotes, this value is case sensitive, right? So if I change this g to lowercase g, notice I did not get the right result. So it's important to know the case. Otherwise, you could convert this to lowercase and then convert the value to lowercase and then compare it. However, there are other operators that we could use for greater than, less than. It's important to know not equal to is actually represented with this value. Depending on which system you're using. If you're using MySQL, Oracle, it might be slightly different. Sometimes you might have exclamation equal to, which is similar to what you know in C#, not equal to. Between is a very good operator as well, greater than, less than, or equal to, I think you can figure out. I'll show you an example of in. The way in works, you could test multiple possible values against a given column. So think of a where clause as very similar to an if statement, right, in SQL. That's basically what it is. So an if statement has a condition. So this is a condition we're testing for to filter the results. Now we have the ability to say where country equals Germany, or is the keyword. Notice all those keywords are in blue, right? It tells you you're doing something right. But if I want to test for customers who are from Germany or from France, I would do something like this. This means I'm going to repeat the name of the column for each one of these. And it's probably easier for you to start thinking of this as a condition by itself so you don't get confused. You put some parentheses around it. You don't need the parentheses, but it's a good convention to get you to think, I need to type in the column name and then some operator equals something. This column name doesn't have to be the same as this, right? We could be testing for country in this example and test for city in the other example, right? So in this case, I'm looking for customers who are from Germany and France. If I run this, I get some customers from France, customers from Germany. It's important to note the logic though. I'm going against customers who are from Germany as a record being with the country equals Germany, or a record which has country equals France. Now, in spoken language, you might say, find me all the customers who are from Germany and France. It doesn't mean that we're going to change this to and. So make sure you get the logic right. If we were looking at the and operator, for example, if I change this to and, so now I'm saying I'm looking for customers who are from Germany, and they're also from France, right? So I need each record to have this match up on this condition. It's virtually impossible. So I'll come up with no results, right? Because no row has a customer with a Germany value and also a France value. Now, alternatively, if I were testing for a condition like this, I could, if I'm testing just one column, right, with something like this, I could use the in operator. And the in operator allows you to have kind of an array of values, right? So country is a column that is some textual data. So I have Germany in, I have this whole thing in parentheses. So in this array, right? And it's comma delimited, as you know, for arrays. So I have single quote around both values. So now I could test for country in this list, this array list. And I don't really have to repeat the column name multiple times. This is only feasible if we're testing for a specific one column or something like that. But you can have in this and something else, right? You can have any number of combinations of this. So you see this brings back Germany and France, 22 records. So that's how the in operator works. Now let's learn about the like operator. So the like operator is a very powerful option. Number one, let's look for a country like Germany and see what we get. So country like Germany, we came up with 11 records. Now notice when we did country equals Germany, with lowercase g, we did not find any records. That is because that is case sensitive. When I switch to like, I could actually find things that look like Germany, right? So lowercase g it forgives me that I didn't know the right casing. So you can use like as a very powerful operator for doing these types of searches. Now, let's say I'm looking for customers who have a country value that contains GER. That's when the like operator really shines. So the like operator has a couple of wildcard values. There's the underscore on your keyboard, shift, your minus sign, underscore, or the percentage. Percentage is more popular, right? So percentage would be in place of anything that we're not aware of. So I'm looking for something that starts with Germany or GER. I would put percentage inside of the single quotes, right? Something like that. And I would have the keyword in between those percentage values. So if I run this, you don't see any difference because it finds Germany. I could look for cities that end or that contain IN somewhere in the city name, right? So that's in between the percentage signs. So Torino, this IN in here, this IN here, this IN at the end, this IN here, this IN here, right? So that's what the percentage sign does. So that allows us to do a contains search. There are at least three key types of searches. So this is one of them, contains. Another example might be ends with. So when we want to find something that ends with IN, we'll get rid of that percentage. Wildcard for we don't know what the beginning of this word is or keyword is, but we know what it ends with. It ends with IN. So find me all cities that end with IN or PEN or something like that. So in this case, we're looking for IN. Before we run the query, we have some values that don't end with IN. They just have IN somewhere in the text. So now I'm going to run that. And I only get 2 cities in this database table that end with IN. So you get the concept. Alternatively, we could do begins with IN. So I know it starts with IN. I don't know what it ends with. So I would put the percentage sign at the end for all the stuff that I don't know. It's the wild card for all the stuff that I don't know. So that's how the where clause works, right? Obviously, you could test for exist, is null, things like that. Another concept to be aware of, we could try to find a list of the first couple of values in a database table. So let's say we're interested in finding out the top 5 customers. So let me change this back to star so we can look at everything. You can just type in top 5. Depending on which system you're using, if it's SQL Server, you could type in top 5 to get the top 5 records in the customers table. You could look for the top 20%. If you're using MySQL, it would have to be select star from customers limit 5. For this website, if you opened it up in IE, Internet Explorer, then you'd have to use top 5. If you open it up in Chrome, which I recommend you do, then you would have to use limit. So if I were to run this, here I get an error. Could not prepare this. That's because I'm in Chrome, which I strongly recommend you use, and Chrome doesn't get this. So to do this exact same thing, I'd have to use limit 5. So give me all customers and limit the results to 5, right? This is running MySQL when you're running this app or web app in Chrome, right? So I get number of records 5. I'm going customers, right? So this is the top 5. Now I could look at the top 15 records. Give me the 15 records. This is helpful when we're paging through results. So you're on a results page and you're paging through page 1, page 2, page 3. Each page has a limit for how many records we're showing, right? So that's how you do that. We've already looked at this in the end and the or. Another key concept, you could do a distinct. So I can look for all the distinct. Distinct means unique. Right? So when we want to retrieve a number of unique values that don't have duplicates, right? Let's say I want to look at distinct cities. I'm not going to limit it since we know that concept. So there are 69 cities in my customers table, although there are 91 records in the customers table. Only 69 unique cities, right? I could look at unique countries. So unique countries, there are 21 of them, right? So that's what this is. All right. We can also have aliases. So I can do something like as my country, and notice the column name as it displays is changed. So I created an alias for a given column that I'm retrieving. And that's nice that you could do that. I have not changed the name of the column. For display purposes, I am simply showing it as that. Some systems would allow you to do something like this, so you don't need the as keyword. Lots of people think you absolutely need it. It's optional. So I just have country, and I maybe want to show a space between the names. So ideally, when you're designing your database table, do not have spaces in the column names, because it makes it difficult to write SQL code. You're going to have to put square brackets around the column names, right? So in this case, I have square my country, so I can show it. When I show it, I would have spaces between the, make it more legible. But the actual column name in the database table could look something like that. So that's what aliases are. And that's the basic concept. Now let's get into how to insert data into a database table. So to add data to a database table, that command is fairly simple. You're going to have insert into, and you need another keyword called values. You need parentheses for the actual values, and they'll be comma delimited. And then you need to know the table name. And then you can add a list of column names. Column name 1, column name 2, so on and so forth. Actually spell this correctly. Then you might have some values. Value 1, comma delimited, value 2. The only thing to be really cautious about is that the insert statement, the way it works is the first value in this array or list of values would be matched up to the first column name in this array. So this says put value 1 in column 1, put value 2 in column 2. Okay, there's no way for you to say column name is equal to value 1. So the way the system actually understands this is by positioning. This is position 1, maps to position 1. Position 1 here, maps to position 2, right? There might be something like that in your quiz question, so I want to make sure you get this concept right. All right, so let's practice this. So before we run the insert statement, I'm going to look at a structure for, let's say, the employee table. So I would do a select star from employees. And there are 10 employees in here. And the last employee has employee ID number 10. Okay, I'm going to show you a best practice here. So I want to add an employee named Iverado, which would be my name. I want to be an employee in this company. So the table name is employees. Substitute. There is a column called first name. You need to be able to match that. If you, it's probably better off to copy and paste so you get it right. So if you mistype this, then you would end up with errors, and you'll spend all your time troubleshooting why it's not working. And I'm going to add Ivor adder as the name. So I want this to be first name. I want that to be last name, right? Run SQL. It tells me you have made changes to the database. Rows affected 1. Now notice I can't see the results. That is because to see what I just did, I need to run a select statement. So I've done it, and it was successful because there are no errors, but I can't see it yet till I go back and write a select statement. So I am going to undo, back to select star, run it, and now I have 11 records, and all the way at the bottom, I would have 11, my name, and some null values because I did not plug in all the column values. So we'll use this to learn how to write the update statement, right? So you get the idea. Now notice when I ran that insert statement, I did not provide the customer ID. That's because this table is smart enough. It's been set up with identity as the employee ID identity value. So it's using numerical values, right, for the primary key, which is what I'm strongly recommend you do. Otherwise, you're going to end up spending too much time making things work. Because this is a numerical value and it's set as an identity column, it would automatically add 1 to the last value. If you didn't make this a number, you'd have to go fetch the previous employee ID, increase that by 1 programmatically, then now create the new row. So you'd have to do a select statement, get the last employee ID, add 1 to it, and use it to create that. We don't want to do any of that because that's a waste of your time. You could simply do a straight insert statement. It works if you make the employee ID primary key a numerical value and set it to identity. So that's the basics of an insert statement, right? That's the basic structure. Let's move on to the next type of statement. I'll go with update. So how do we update something? So let's say we're going to go ahead and update this employee record that I just created. So that statement looks something like this. If I can actually spell, update the employees table. So we need to know the name of the table. Then we can set specific column to different values. So let's set the notes column. So the notes column value for me is null. right? Because I did not provide anything for that in the first instance. So we'll do that. So set notes, make sure that's the name of the column, equal to, because that's going to be some textual value, I'll put it in new employee, yay. All right, so there's a new employee, but we must have a where clause. If I do not add a where clause, which is possible to do, I could just do update employee set notes to this. It's going to change the notes for all of these employees to this value because there's no where clause. There's no condition under which to do this. It's just going to do it for everything. That's how you get fired as a database administrator. You forget to add a where clause to an update statement. Right? So where clauses, as we studied in the select statement, very critical for updates and deletes. Right? Similarly, you don't want to write a command that says delete all rows in a table unless you explicitly wanted to do that. Right? So we need to know which specific value you want to go after. I can go after, maybe I know the last value of this employee ID was 11. Notice I don't have single quotes around it because employee ID is a numerical column, right? It's an integer value. It auto increment. So I can run this. Hopefully that works. And it says 1 rows affected. That is good to see. And I'm going to select star from employees to verify if that actually worked correctly. So I go back in, still have 11 rows. This is Auto, and it's got new employee, yay, right? So that's how the update statement works. The next statement to be aware of is the delete. Where employee ID equals 1. Right, so we run that. We see 1 row is affected, and now we can go back and do select star from employees. Let me change that. And we'll see the results. All right, so that's gone. Let me go back and recap one other thing that I might have missed. When we need to sort data, we would use what's called the order by. So order by keyword, right? So if we want to sort, let's say by employee last name, we would have the name of the column. And so we could do something like this, sort by last name, and you see my name shows up first. So that's sorted by this. By default, this is sorted in ascending order. I can also put the keyword ASCS. If I want to sort in descending order, I would do something like this. Order by last name, DES short for descending order. And now West is the first one that shows up. So that's how you sort. So those are the basic things we need to know about SQL. If you've completed this video, you should be able to answer all these questions. Best of luck, and talk to you soon. Take care.